So we have three things we're going to talk about here, three things called set operations. Specifically, they're what are called binary operations. If I have two sets, I'm going to do some things with them. All right, so the first thing I want to do is this idea of a union. A union of two sets is written with this. It's not quite a U, right? The font is a little different, but it looks a lot like a U. This is the symbol for union. And it's the set of elements that are members of both A or B. So it's like the two original sets just combined together. Right, so let's look at some examples here, right? And see how we can come up with some of these unions. A union B. What is this? Well, it's a very brute force thing. I'm going to write out all the elements of A, then I'm going to write out all the elements of B, and that's it. It literally is the two sets just brute force combined together. Now, one thing we don't want to do, though, I have to do a little cleanup. We don't want to have duplicates. So I see I've got the number 2 on here twice, and I've got the number 4 on here twice. So I'm going to remove those two duplicates, and that should give me my answer. It's the set 1, 2, 3, 4, 5, 6, 8. All right, so let's try another one. Let me give you one here if you like. You can pause this and try to work this one out. What is A union C? All right, well, again, I'm just going to write out my numbers. 1, 2, 3, 4, 5. That's A. And 1, 3, 5. That's C. Now let's clean up the duplicates, right? I've got 2 1s in here. I've got 2 3s and 2 5s. And that leaves me with 1, 2, 3, 4, and 5. Look at that. I'm actually back where I started. That is the original set A. Now that was a little unusual, but think about the relationship between A and C. C is a subset of A. That's kind of why this happened. All of the elements of C were already in A, right? And that's why we ended up just back where we started with the original A set. Okay, so how about intersections? Right? The intersection of the set, you notice how we've got a notation for this as well as this kind of, it's an upside down U. These are the elements that are in A and B. Think of it as being what the two sets have in common. Right, so let's try this out as well. Let's look at A intersection B. Okay, well, here's what I'm going to do. I'm going to go to the set B because you can do this either way, but B is the smaller one. If you base this off the smaller one, it's a little less work. I'm going to go through every element of B one at a time and ask myself, is it an A? If it is, it goes on my list. All right, so let's see. 2 is in both sets, so that makes the list. 4 is on both sets, so it makes the list. 6 and 8 are not. Right? 6 is not in A, neither is 8. So that's my intersection. Right? The two numbers that they have in common. Okay, so again, let me give you one. I give you the interesting one. How about the intersection of A and C? Right, what do we end up with here? Well, again, C is the smaller set, so I'm going to kind of use that to drive the process here. 1 is in both sets, so it'll go in my intersection. 3 is in both sets, so it gets to go in my intersection. And finally, yeah, 5 is in both sets, so that goes in my intersection. Look at what happened. That is equal to C. And again, this is that subset business, right? Because C is contained in A, right? And C is the smaller of the two. Those are the two those are all the elements that they share. All right, now let me put one more up here, right? And actually, let me clean up a little bit first. Get us some space here. How about how about B intersection C. What is this? Let's walk through C, right? 1 is in C, but not in B. 3 is in C, but not in B. And 5 is in C, but not in B. They have nothing in common. Right? Nothing in common. So what am I going to say here? Well, I need a set that has nothing in it. See why we need the empty set? Right? The intersection of B and C is the empty set. It's the set with no elements. All right, so we've got one more here, one more set operation. This idea of difference, right? The difference of two sets, and it's written with a subtraction symbol, right? Just symbol you're used to thinking of for difference, is the set of elements that are in B but not in A. So really, literally think of this as subtracting out, right? Subtracting out. So let's actually do B minus A. So what I'm going to do here is I'm going to start with my B list, and I'm going to cross out everything that's in A. All right, so let's see. 1 is in A but not in B, so that's okay. 2 is in A, so that has to go. 3 is not in B. 4 is in B. And 5 is not. So what's left? When I took away everything that was in A, all that's left is 6 and 8. All right, so again, let me give you one. How about B? Well, let's go the other way around. Let's do A minus B. Try that one out. See what you come up with. Okay, so now I'm going the other way, right? I'm gonna start with the A and take out the B. So I'm going to take out the 2 because that's in B. I'm going to take out the 4 because that's in B. The 6 and the 8, they aren't in A, so all that's left is 1, 3, and 5. And you notice, right, I got something different. That's kind of what we expect from subtraction, right? Subtraction of numbers isn't commutative. 3 minus 5, 5 minus 3, different things. Same thing here with sets, right? Exact same thing is happening. All right, so how about larger expressions? Well, look at this thing, right? I want to figure out what is A union B minus C. Well, what would you do if I asked you to find 3 times 4 minus 6? Well, you do them in pairs. Right? I would simplify this part first. 3 minus 4 is 12. 12 minus 6 is 6, right? You do them in pairs. I'm going to do the exact same thing with my sets. All right? First, I'm going to figure out what is the union of A and B. Well, that is the set, let's see, 1, 2, 3, 4, 5, plus 6 and 8. 1, 2, 3, 4, 5, 6, and 8. Minus, it's a little hard to see sometimes, but there's a little complement symbol up there. What is the complement of C? Well, I've got my universal set, and I'm going to take out everything in C. So I'm going to take out 1, 3, and 5. And what's left is 2 and 4. All right, now I'm going to do the subtraction. I'm going to take 2 and 4 away from this set, and what's left will be my answer. So take away 2 and 4, and what's left is 1, 3, 5, 6, and 8. That's it. That's my answer. Okay, so we've got another one here for you to practice with, but if you're taking notes, finish writing them down first, because it's under where I was writing. So I'm going to have to clean this up. You can pause if you need to. Okay, try that one. A minus B complement intersection C. Okay, well, first let's do A minus B. Right, A minus B is, I'm going to take 2, 4, 6, and 8 out of A. So I've got the 2 and the 4. Right, so that is A minus B. A minus B is 1, 3, 5. And I still have that complement, intersection C. All right, so what is the complement of 1, 3, 5? We'll go to the universal set, cross off 1, 3, and 5, and what's left is the complement, 2, 4. And I want to intersect this with 1, 3, and 5. Well, what do these two lists have in common? Nothing. Right? When two sets have nothing in common, their intersection is the empty set. That's it. That'll be my final answer.